In this video, we are going to experience Metaspex's automatic referential integrity enforcement. We start from three documents, the three large triangles represented on the screen. The circles inside the documents are objects. All objects are instances of user-defined types, part of the ontology being used. Only a data model is needed for referential integrity to be generated by Metaspex for all the events shown in this video. Solid arrows represent strong owned relationships, while the dotted ones represent strong links. Strong relationships indicate that the origin object cannot exist without the target one. Relationships starting with a round with a cross inside are composite relationships, also called one-to-many. Metaspex calls them list relationships. We are going to witness the actions taken by Metaspex when an object is cut. Cutting the object is simply done by calling cut on it. The object is now colored in red to show that it will disappear from its document. During cut, Metaspex will start following the relationships which target the cut object. Let's see what it does first on a link relationship. The relationship turns red, as cut should break it. But it was specified as a strong link, so the object at the origin of the link must disappear from its document too, as it cannot exist without the target object. Little by little, in cascade, strong relationships are broken, and the objects bearing them must disappear too. The process continues up to the point the document root object must disappear too, meaning that the entire document will have to be removed. Metaspex now selects another link pointing at the object which was cut originally and follows the same process. In this case, the link is composite, meaning that it will simply shrink without having to propagate anything to the origin of the link. The object bearing the link list stays in its document. The process keeps on going automatically following the same patterns. This last link needs to be broken too, as it is targeting an object which is inside a sub-document attached to the object which was cut originally. This step is very important, as it performs deep referential integrity maintenance and would require a lot of efforts if done manually with software written by hand. Now that all the impact of the cut has been established, it is time to remove objects from their documents and to remove entire documents if needed. The entire document on the left needs to be removed. The links between the document on the right and the document in the middle are simply removed. Eventually, an entire sub-document is cut, leaving referential integrity in a correct state. Imagine programming all this by hand. In this example, nothing needs any kind of programming as referential integrity is enforced purely from the data model.